So in this video, we're going to process the M13 Hercules cluster with PixInsight, and I'm going to try and use some of the scripts from the Easy Processing Suite. And I've done if you haven't heard of that suite before of scripts, I've done a video which I'll link below in the description, showing you how to install it and set it up. Very easy to do. And what this does is it gives us access to 6 different scripts. Today we're going to try and use the noise, maybe the HDR, and maybe the soft stretch script, just to give you a feel for those. So this is the image loaded into PixInsight. It has been stacked in Astro Pixel Processor, and it is 50 light frames at 120 seconds each, plus calibration frames, and it was taken with a Canon DSLR unmodified camera. And obviously we loaded in here, it's unstretched, just stacked, and we start off, we can press the auto stretch, which shows us what the image would look like, I guess, as a computational stretch. So remember, when we're using these stretch buttons or auto stretch buttons in the corner here, nothing is actually updated or edited on the picture. It is just a calculated view of what a stretch might look like on the image. We can remove that stretch, and this is what the actual image looks like right now. And we can apply the stretch just to help us see what we're going to be doing for the first several steps. So to start off with, quick look, we can see we've got some stacking artifacts here in the bottom left and the top left as well. And then on the left-hand side to the right-hand side, we've got this light or gradient going from light to dark on the right-hand side. So hopefully we can flatten those gradients out. However, the first thing we're going to do is remove these stacking artifacts using dynamic crop. And to do this, we just open dynamic crop process and click and drag around, and you can see this box appears with a nice little X in the middle to show us what the center is of the crop region. And we're just going to center that on the cluster itself. Now this cluster, it's not a large object, I suppose, or target within the area that I've imaged. So I'm going to reduce that area slightly a little bit more by cropping more of the original image out. So while you're doing this, obviously just check to see, you know, it'd be nice to include these 2 little stars down the bottom left-hand corner, which looks like a blue and an orange. And I'll just up a little bit as well to bring in these 2 stars as well. So when you're cropping, obviously think about how you're framing are going to be framing your image. Okay, so that's the area I want to crop. We just run the dynamic crop for us, and we can resize, and that's the image that we'll be working with. And we'll just close dynamic crop. Okay, so we're going to work on the gradient, which I said before is left to right, which is light on the left-hand side and darker on the right-hand side. And to do this, we are going to use dynamic background extraction. Now, dynamic background extraction allows us to analyze the actual background of the image rather than the foreground, which in this case is the cluster. And from analyzing the background, we'll see a calculated model is created which captures the gradient, and that is then removed from our original image. And after that, we should have a solid background right across the image, so there is no gradient flowing through. So the first thing we're going to do is look at the tolerance value, and a high tolerance value identifies brighter pixels within the background, and these pixels will be picked up within the model. But the problem with that is if we go too high, then it risks picking up pixels that are not defined or that are not the true background. Likewise, if we decrease the value or the value goes too low, we are more restrictive in the calculations, and low tolerances will not sample the background correctly. So it's a bit of a try it depending on your image. But I know for this image in previous tests or trials, 1.5 has worked out quite nicely for myself. So we'll set that at that. The sample generation, because what DBE does is it samples the entire image, but this is where we define the size and how many samples we want to take. First thing we're going to do is change the sample color. So this doesn't actually affect any of the calculations or the sampling. This just means that because we've got a dark background, our sample areas will be highlighted yellow. So it's just easier to visually see what's being sampled. I'm going to leave the sample per rows to 10, and I'm just going to slightly increase the sample radius to 15, and I'm going to generate those samples. Now, you don't want your samples small, as in a radius of 2 or 3, but you don't want your samples very, very large either, because what you're trying to do here is make sure you've got a gentle calculation across. We'll see later on when the model is calculated for the gradient. Hopefully it'll be nice and smooth and nice and gentle. I find that if you have larger sample radiuses, and so forth, the sample areas are much larger, sometimes that calculation or model that's going to be removed, it's not smooth, and therefore doesn't quite remove the gradient as nicely. So what we'll do here with DBE is basically we're going to be using this next button at the top to go through the 74 samples that has been generated based on our tolerance and based on the sample radius and based on the samples row. And what we are looking for here is to make sure that each sample box has a nice clear background. And how we know that is if it is a black area, such as here, then we are sampling a star. And a star in this instance is not our background, so therefore the background calculation will be incorrect. So all we'll do for these ones where there's a black area or a star is just slightly move the sample box, so just click and drag away from the star, so we've got more of a white pixel effect, I suppose. So we know that this sample box is sampling the background as opposed to the star. Click on next. We then go to sample 2. That looks good. Sample 3 looks good. 4, 5 is a bit on the edge. We'll leave that one. 6, 7, I'm going to move slightly again. We've got a little bit of stars there. And we just repeat this for the 74 samples. So I'm just going to fast forward the video at this point. So there's another one. I'm just moving slightly out, and I'll start up again once I've checked off all of these 74. Okay, so I've been through the 74 there, and the next thing we're going to do is we need to set the correction to subtraction. So what this does is the model that's calculated, it is subtracted or removed from our original image, and thus hopefully removing the gradient. I'm not going to set normalize, and I'm going to I don't want to discard the background model. I want to show you that. So you can check that if you want. And I'm not going to replace the target image either. I want to show you, I'll use the new and the old images as kind of like a before and the after. So if you want to speed things up and yourself, you can click discard background and you can click replace target image. There's no issues with that, but make sure correction is set to subtraction. So we're going to execute the actual calculation and extraction itself. Okay. And what we're going to show you is the background So this is the model that's been calculated. And if I show you the original image again, remember we have a light background in this corner going to dark, and on the calculated correction, we've got light in the corner going to dark as well. So this is like a nice smooth gradient, or not, sorry, a nice smooth flow. If it isn't smooth, what I would suggest doing is looking at your tolerance or looking at your sample radius and trying again to get it nice and smooth. So this background is what is subtracted from the original image, and this then creates our new image. So I've just auto stretched the new image again, so we can see the subtle differences. I'm just going to close out background extraction process, put these side by side, and then hopefully we can see the difference of before and after. So on the left hand side here, we've got again light, maybe pollution going across to dark in the corner, whereas the one on the right hand side here, it's much more flat across. So yes, there is a lot of noise in this, as we generally see with DSLRs in the background still, but we'll look at that in further steps. So left-hand side one is what we started with. I'm just going to close that. And remember, if you had checked the replace target image, you would have just ended up with one image there, as opposed to what I've got there, the two. I just wanted to do that to show you before and after easily. Okay, so moving on, we are going to look or start looking at the color calibration of this image. And one of my favorite processes is the photometric color calibration. Now I'm just going to reset this so everything's back to as is. Now the first thing we're going to do, working from the top to bottom, is we need to search the coordinates for M13. And what it does, why it requires these coordinates, is it uses it in the background for a bit of kind of plate solving, or allows PixInsight to understand the target specifically, or the area within night sky that is looking at. And based on a catalogue of information, an astrometry catalogue, it can then color calibrate based on the location. So one of my videos shows you how to download and install the catalogs locally. So that actually speeds the process up a little bit, rather than having to go online and search through this catalog remotely. Everything is done locally. So if you're interested in that video, you haven't set the catalogs up, again, I'll put the links in the description below. So search coordinates, and we would just type M13 in here and click on search. It's found the object M13. It's found the right ascension and declination of where this is in the night sky. Click on get, and it populates those values for us here. The next point that we need to change is the observation date. And again, this is to do or help it plate solve and know where it's looking in the sky. So 2021, I'm just going to put the October the 5th, which was approximately when I took it. You don't have to be 100% accurate on this by setting the time and date, but the nearest you can, the better. The focal length is the focal length of my telescope, and the pixel size is the pixel size from the DSLR camera itself. Your focal length and pixel size will probably be different to my own, obviously different equipment, different telescope, etc. So please look those up. And it does make a difference in the calculations, so make sure that you are as accurate as you can, especially on the focal length and pixel size. Okay, so I've got automatic catalog checked. So this should use the local catalog rather than going online. We'll leave everything else as is, and we just simply run this process. Okay, so the color calibration is finished. We'll get this graph which shows us all of the stars or the points that it's calibrated. You can click on the question mark here to get a little bit more help text to actually what the image, what this graphs are showing you. However, to myself, the most important bit is what does our image look like. So the image here has been color calibrated. If we do an undo for that process and then a redo, we can kind of flip between the before and after. So obviously the after, you know, it's not a solid black or background. There's a lot of green haze in there. If we redo it, we can see a bit more that the background is improving and the actual cluster itself is looking very, very nice with some color, oranges, whites obviously coming through. And also some of the larger stars, the orange ones, they've been improved as well. So photometric color calibration, I know there are a few other ways to calibrate your image or color your image, but this one is personally my favorite. Okay, so we're going to close that. Now, one thing that we get with DSLRs and a lot of cameras is kind of a green tint against our image, and we can remove that. Where is it? Using SCNR. Now, SCNR, we're going to remove the green, so just leave that as green. And you might want to try different strengths of this process. I'm going to drop this down a little bit to 0.65 and run that against the image. And if we do a before and after, you can kind of see again the green tint that was especially on the dark or the black areas has been removed. Okay, and we'll close SCNR. Right, so we are now on to noise reduction. It is not noise removal. We're not actually removing as such. We are just reducing the amount of noise in the image. And to do this, we're going to use one of the Easy Processing Suite scripts called Easy Denoise. And you just got some warnings that, you know, I guess it's not a PixInsight process. It's a third-party process that is still under heavy development. So to use denoise, what we do is we first select our image, and with all of this, I'm just going to hide this. Let's just try and hide this. I don't want the window sticking out. Let's run it again. That's not going to disappear. Anyway, to run denoise, we need to select our image, and this actually runs, or this script. Just going to reduce the window size there. Opened a little too large. So this script actually runs TGV denoise, and it runs multi-scale median transform. And you can run these manually through the processes. This script is just basically taking some self-calculations against the image. It creates a favorable mask, and then you can still change the settings again, just as if we did TGV and MMT on its own. However, as I said, behind this script is some calculations which hopefully outputs the best masks and the best settings for your image itself. So what we'll do to use this, I'm just going to keep everything as is, and for speed wise, you'll see this in a minute. I'm going to just reduce the iterations down to about 200, and TGV is very an iterative process. It goes, you know, kind of a gentle or subtle change for each iteration. However, when we are just evaluating or seeing a temporary look at this, we'll just do a small number of iterations to speed things up. So I'm just going to evaluate everything with settings as is, except the iterations. And what you can do if you have got a really slow machine, PC or laptop, You could do this just on a preview window if you wanted to do that. We're just going to go for the full thing, and we'll just let that run at 200 iterations. So in the background, it's automatically calculated and set a mask. And if you look on a website by John Rister, which I've made reference to in one of my previous videos, you can see the details that are used and how he creates his masks. And this easy denoise script uses his methods. So we'll let that run and we'll come back when it's finished. Okay, so now when it's finished, it's evaluation, because we get this second tab at the top. And on the right-hand side is just confirmations of the settings that were used. And if we zoom in here, we are currently on denoise run 1 tab. And I click on the M13 stacked DBE. That is our original image before the process was run. So you can clearly see here a lot of pixel noise, which is our original image. And then if we click on the run 1, you can see a lot of or less noise, etc. So as I said, we're not removing noise, we are reducing noise. We can scroll in and scroll out of that. Slow there. And then we can easily compare different areas as well. So I'm just scrolling along to the right hand side, and you can see again, this is just above the top of the cluster, and a lot of the background or the dark side of things will certainly reduced the noise. Okay, so as I was saying, the noise process, it's iterative, so it keeps repeating. And we did that sample with 200 iterations just to make sure that, you know, what the settings or the default settings were right. And I'm going to increase this iteration number all the way to about 2,500. One thing I'd say about the Easy Suite scripts is, yes, they are replicating or, you know, making the PixInsight processes easier. However, if things do go wrong or things don't go right, or don't look right, it does help to have that understanding knowledge of the individual processes or what the settings are, so that you can adjust to try and improve any output of that. But generally, in using these easy scripts myself, I'd say 90% of the time, a lot of the default settings have came out or produced good results. So back to this, I'm just going to increase the iteration to 2,500 or thereabouts, run with these settings. PixInsight or the script's gone off to do its thing. As you can see, it creating the masks in the background there, based on the John Rister method of calculating how to make masks. Again, if you're interested, I'll put the link below. Have a read on his website, especially about noise reduction, and it is a very informative read. So this will take several minutes, so I'm going to fast forward the video or cut the video at this point, and we'll come back once the Easy Denoise script has finished. Okay, so the Easy Denoise script's finished. And let's see if we can do a before and after. Oh no, the mask's on it, so it's not going to show us easily enough. But anyway, we've gone through 2,500 iterations. There is a little bit of noise remaining, but again, we'll continue through the workflow and we'll process that out. So at this point, what we want to do is convert or perform a non-linear image stretch. And again, similar with a lot of things in PixInsight, there's multiple ways to do this. However, I'm going to try it with the easy soft stretch. So we could have done this with a screen transfer function and applying that within the histogram transformation. But as I say, we're going to try and use the easy soft stretch to see how that works. So we select our image, and then you can see on the left hand side here, It's doing some calculations against the image, and what we need to adjust is the target median and the expand low value. The other thing we can do is we can zero in on a white point. That may help, but then again, as it says here, there's sometimes a bit more of an aggressive stretch. So let's just try that width, just expand our image here so we can see what's going on. And if we increase the target median, obviously you can look on the right hand side, but also look on the histogram. So you can see how this has shifted the histogram to the very right. Whereas what I'm trying to do here is, without cutting anything off, where it starts to slope up, is move this to the left hand side, and that should give us not just a stretch, but a bit more of a darker background or a darker image. So let's drop that median right down. Okay, and you can see there we are getting a little darker. I'm going to reduce the expand low. So just playing around with these sliders to see what works best, again, depending on your image, target, or actual hardware or camera setup. You may need different values with this. So please just try, I guess, what's pleasing to the eye, but without cutting too much of the histogram off. So just going to try with 0 in on the white point, removing that. You can see every time we change it, it does some calculations in the background, especially in this green text area. If you want to look what it's doing further, I'm just going to continue to play with these sliders a little further. So that's complete, and we can now see the stretched image, and we can do a before and after. So if I reverse this out, obviously it's unstretched, so we have to auto stretch or boost it. And then if we go back to after the easy stretch or soft stretch, we can now see the stretched image without having to do the auto stretch functionality. Okay, so we've still got a little bit of noise in the background there, and we're going to use a process called ACDNR. I'm just going to minimize these masks that easy denoise and the stretch have used. Don't need them any further. Okay, so ACDNR, this is a tool or process for, again, can be used for noise reduction after the initial stretch that we've just completed. So we're going to create a luminance mask first. So we can just press this icon here. That extracts the L or the luminance component. I'm just going to adjust this mask or this image before we create it into a mask. So we go to, where is it? Screen transfer transformation, and we will also need histogram transformation. Just going to reset these. Okay, so for the luminance, I'm just going to nuke this image, and then I'm just going to apply the screen transformation into the histogram transformation, and you do that by just clicking and holding the triangle and dragging that up. Okay, and if we just select DBL, which is DBE luminance, we can then see for the histogram for this. So I'm going to put a preview on for that, and what I'm trying to do here is adjust the mask or the luminance until we've just got the stars in the background. Okay. So basically, moving these sliders along, when you use the mid-tone one here, move it to the right-hand side, and you can see very slowly we're going from a high contrast real-time preview along, keep on going, we're getting more to the stars in the background itself. So we don't want to go too far, because then we're excluding too many stars, and what we want to do is get that balance of the left-hand side where everything's high contrast and to the right. So what I'm trying to do is just at the tip of where the background goes all black or solid, is where we want to take this histogram adjustment to. Okay, so we'll go with that, and we apply the histogram transformation to the luminance channel. And then to apply the luminance channel as a mask, we just click and drag it to our main image underneath. And once this tab goes brown, it shows that there is a mask applied. And obviously we can see there the red is the mask. So red means protected, and we want to protect the stars. So they are white at the minute, so we need to invert that mask. So invert it, and you can now see the stars are red being protected, and it is the black background that we are going to reduce the noise on. So I'm just going to unshow the mask. So the mask is still applied again because of this brown tab. And we're going to select a preview window just to speed the processing up, or the trying of this. And then we're going to go back to our ACDNR. Again, you'll get different mileage out of different amounts and different iterations on this. I'm just going to iterate a little bit more over. So it's like subtle changes per each iteration on the lightness side. And we're going to reduce the structure side. We don't have like a large structure such as a galaxy in this image. And then on the chrominance side, I'm going to reduce the amount slightly as well. So again, it's an iterative process, up the iterations to 5, and again, reduce the structure. So we're going to apply this to the preview, and hopefully this will reduce the noise on the background a little bit further. And just with the preview window, we can do a before and after. So if I zoom right in there, there's still, slightly bits of noise. We're never going to remove everything 100%, but there's a before, a lot more pixels of noise, and there is an after. And remember, due to the mask, this has only been applied to the background and not any of the stars. Okay, so we can remove the preview. We don't need that anymore. We'll go back to our main image again with the mask applied, and we run the ACDNR process against the image. And then we can do a before and after on the image itself. Obviously, the main area is the cluster, but we can do a before and after the site, and we can see again the noise has been further reduced. Okay, and I'm just going to remove the mask, and we can minimize the luminance that we used to create the mask. Okay, so we might want to do a slight stretch at this point with the histogram. So let's look at the histogram to see if that will help us. And just reset, and we are going to reselect our main image. What I want to make sure here is these percentages show how much data is being clipped. So we want to keep this as low as possible. I'm just going to bring up the shadows on that. Actually, we'll run a preview first so we can see what's going on. We're going to increase the shadows without clipping. So as soon as we go too far, you can see this number just spikes, and that means that we are clipping data out of the image, which is what we don't want to do. We don't want to lose any information. So it's just a subtle stretch to make sure that we can go as far up with trying to keep 0%. And this stretches and just slightly adjusts the background again for us. Again, so each of these steps are bringing through a little bit more color and a little bit more information from the image. Okay, so we can use the before and after on the preview. Happy with that, and we'll just apply that slight stretch. Okay, so one of the areas with clusters, and I guess similar to galaxies, is making sure or trying to reduce the burnout in the middle of the core, where to the eyes, I guess it's too much white, or it's overexposed in the middle. So there's a few ways, again, within PixInsight we can use to reduce this, such as range selection, and then applying that within a local histogram equalization is the process that's called. However, we're going to try and continue with some of the easy processing scripts, and we are going to use easy HDR. So again, HDR is also a separate process within PixInsight that you can use directly. And I'm just going to choose our target again, which is DBE. Now, for some reason, I keep getting this warning, and it says this script only works on non-linear images. However, we are in the state of being non-linear, so I'm not too sure why this appears. But anyway, let's continue anyway. And again, as I said before, generally I find that 90% of the standard settings for easy scripts are good. I'm just going to slightly increase the layer on this by 1 level, and all we do here is just run the easy HDR script. So you could see there quickly it's creating some masks, calculated masks again, and now it's applying the HDR actual process. So if we just open these masks of the process there, you can see there's the mask that it's used on my image for the HDR process. Just going to reduce those. We don't need those, actually. Move them down into this corner. And then what we're looking for here in the center, we'll do a before and after, is improvements to the core. So this is the after of the script, and this is the before. So I'm not sure if this comes through on the YouTube video very well, but we slightly reduced the brightness of that core. So there's a lot of kind of a white area in there, but after the HDR, you can see a few more of the individual stars of the cluster, which is always good to see. So play around with that script if you want, adjusting the 2 parameters. Again, different images, different imaging equipment will get you different mileage or different results. Okay, so let's now look at trying to bring a little bit more color out of the cluster. And to do that, we're going to use curves transformation to start with. And just going to reset. And we'll run a preview. And for this, actually what we need to do, sorry, let's go back a step. We need to create a mask. So when we are adjusting the colors, we are only adjusting the colors of the stars or the cluster or the foreground, and then we can flip the mask and slightly tighten up the background itself. So luminance mask again, per usual. We're just going to apply that, show the mask just to see that's been applied, and then on the left hand side again it's brown tab, and the red is protected, so we're not going to be adjusting the background, and we're just going to be adjusting the colors that come out of the cluster. Just going to unshow the mask, and then we can go back to curves transformation, show the preview, and then what we'll do here is we will slightly increase the saturation. Well, not slightly, but let's see what we need. So if we decrease the saturation, again, this is just changing the stars. You can see it loses a lot of color or a lot of saturation. The stars go very cool or white. If we oversaturate it, you can see there's a lot more color in the stars there. The oranges, the blues, or the whites turn into blues, but that is obviously too saturated. So we need to find a nice balance in the middle. And again, this is just personal taste to how much saturation you want to be added in. I don't like to overcook my images too much. I think it looks a little bit false. So let's just do a before and after on that. Maybe a little bit more. So we can kind of see some oranges and blues coming through, which I like. And then the actual RGB channel itself, again, if we push this too high, we can see obviously way over over the top there. And if we go too small, we'll take all the detail out of the image. So again, with the RGB, we don't want too much because we'll start to burn the core out again. This is just a subtle improvement to slightly bring a little bit more color out. So again, there's no like specific numbers for this or specific parts for the curves. It is just a bit of by eye to what looks good for yourself. So we can remove the preview, add the preview, and again we can see the colors coming through. So I'm just going to apply that to the main image. I'm then going to invert the mask. So just to show you doing that, I've showed the mask again, invert mask, and now the stars are protected, and that's what we've just been adjusting. So show the mask or remove or hide the mask being shown, reset, preview, and this time we're going to slightly adjust the background. So this time I'm going to reduce. Again, if we go too far, everything goes black and looks a bit false. So with the RGB, it's again, just with the eye. Some people like to have a little bit of, kind of color in the background still, I guess space or the dark sky is not 100% black. You don't want to go way down here. Again, I think that looks a little bit false. So just subtle touches with the curves. And we can see if removing any of the saturation. So what I'll do is drag all the saturation all the way down, or the curve all the way down, so we can see what is over the top or too much, so we'll get an idea of what's been adjusted when we're playing with the different curves. So just a subtle one on the saturation, not too much. I'm going to go back to the RGB and reduce that a little bit. Use the preview to see before and after. And then we can just apply that to the image. Okay. Right, so that's looking good. So we will remove the masks. Let's reduce these to get these out of the way. And one final process that I'm going to show you from the Easy Suite is the star reduction. So again, star reduction kind of takes 2 or 3 PixInsight processes and reduces those into one easy script for you to use. So the star reduction in the background is a star mask that's created, and then a process called morphological transformation is then used to actually reduce the stars. So I'm going to choose our image again. Just let's expand that window so we can see what the options are. If we had a mask, that star masks that we'd created ourselves, we could just select it from the drop down. We don't, so therefore I'm going to click create star mask for reduction, and part of the script creates the star mask for us using StarNet in the background. Okay, so this might take a minute. I'm just going to fast forward the video here and we'll come back when the star mask is created. Okay, so raw mask has been created and it's auto selected that star mask for us. Morphological selection, I'll just leave as the top one, and star reduction iteration. So this depends on how much you want to reduce the stars. So if it was like a cluster aside, if the image had a lot of stars in that and you wanted to reduce them to kind of take your attention more to the galaxy or the nebula or whatever it is, you could increase the number of iterations on this. And I guess on our image here, there's not too many stars outside of the cluster. So I'm just going to reduce that by 1 and we'll actually run the script, which also takes into consideration the mask that it created itself. This is sometimes, before and after is very good here. Sometimes it is good to use the star reduction, other times it's not. So let's have a look what that's doing. So to be honest, it's reducing the stars around the cluster a little bit too much. There you can see a redo. So this is with the star reduction applied, and this is before. And to be honest, I do like the image without the star reduction on that. So we're gonna, I've undone that. I'm just going to remove the mask. Let's tidy up a few things down the bottom here, and we can open the image larger. So I think we're done there. Maybe the background's a little bit too dark. Maybe I went a little bit too much over the top on the curves transformation. But as you can see there, you know, it's kind of like, you know, to your own eye, how you want your image to look. I'm happy with the colors in there. We've got some nice orange stars, a few kind of like bluish stars coming through, and then obviously the cluster itself looks nice in the middle. So yeah, quite pleased with that. Not 100% with the background. I would redo that again. As I said, not as much on the curves transformation, but as a walkthrough of a workflow, sorry, for the M13, I think it's good. Please remember with PixInsight, there's 101 ways to do things. There's 100 different ways to run combinations of processes, etc. I'm not saying mine is the best workflow. You know, there may be others out there on YouTube, websites, etc. But this is the one that I'm happy with for my needs. So thank you very much for watching this video. If you've enjoyed what you've seen, what you've listened to, please give me a subscribe. If you are a returning subscriber, then thank you very much for the support on the channel, and please leave a like or a comment below. Thank you.